Welcome back, everyone. Professor Cameron here. Now, what we're going to be working on today is advanced 3D contours in Solidworks CAM. So a lot of what we've been doing has been pretty basic contours, either 2.5 axes or simple 3 axes. But what we're going to work on today is generating the toolpaths for this piece here. Now, this isn't anything in particular. This could be a boat propeller, it could be a food processor blade. Realistically, it doesn't matter. We're going to approach our toolpaths the same way. So, what we're not going to talk about in this video is fixturing, which is a concern that we have when designing any part, but particularly this part because it is two-sided. So we're going to leave out fixturing. That's going to be a topic for another video. We're just going to cover how to recognize the features, how to generate the toolpaths, and how to go ahead and get this part cut out. So let's go ahead and start this part like we always do. We're going to go to SolidWorks CAM, and we're going to define our machine. We're going to be doing a standard mill in inches, and you can use whatever tool crib you guys happen to want to use. Now, one thing I will mention is that for this, we're going to be using a ball end mill. Now, I don't have that loaded into my tool crib, so I'm going to uncheck Use Tool Crib Tools Only so that we can go ahead and add that in later. That's how we're going to get a nice finish on this 3D contour here, is with that ball end mill. What we're going to do is we're going to go ahead and define our stock. Now, like I said, we're not paying attention to fixturing for this. This is just generating toolpaths. So we don't have any considerations like that to take into place. So we're going to generate our stock, and we're going to generate it to the minimum thickness that we need. In my case, it's 5.3, 0.87, and 5.03 inches. We're going to go ahead and click OK. Next, we're going to define our coordinate system. And since we're not talking about fixturing, it really doesn't matter where we place this. But we're going to go ahead and set this up in our traditional fashion. I'm going to set it up in that front right-hand corner. Now, with this, we don't really have a good way to orient our axes, but we should be able to orient them off the planes. So instead of selecting a surface, I can orient my axes off of my planes. And what I'm going to do is I'm just going to select my right-hand plane for my X. And what I'm assuming is going to be my front plane for my Y. And then we can just flip those. Let's see. Flip those. There we go. To get it in our traditional XYZ orientation. We can go to Setup. Now with this, we have two sides that we have to machine. We have to machine the back side as well. And that's essentially going to be the same as the top side. So we're going to go ahead and do both of these in two different mill setups. What we're going to do is select this top surface and select OK. Then what I like to do is just run through this, extract machinable features, generate operations plan, and generate toolpaths, and see how everything looks. And see if there's anything that I have to do. And right off the bat, after extract machinable features, it's not recognizing any of the features on here, which is common when we have advanced geometry like this. So what we're going to do is we're going to go to Mill Part Setup, right-click, and we are going to do a multi-surface feature. We're going to go ahead and select the curved surfaces of this, and yeah, we'll go ahead and select the top on that as well. That all looks good. And what we want it to do is we want it to recognize that feature. Now we should be able to generate the operations plan. And what it's included is an area clearance. That's going to come in, do a 2.5 axes operation to just rough this out. And then it's going to do a Z level with a ball nose. And that's going to cut the actual 3D contour. So let's see how this looks. We'll generate the toolpath. There we go. And we'll go ahead and simulate this. We'll see how this looks. It's coming in here and it's going to rough this material out, just like we would expect. Let's go ahead and speed this up a little bit. Then it's going to come in with the ball mill. And this is where it's actually going to start to sculpt it into that finished contour. Now, we got to tweak all these settings. And if you'll notice, it's leaving quite a little bit of material around the outside as well. We're going to have to go ahead and program in a contour or perimeter pass for this to clean up this outside. But this is a pretty good starting point. So let's go ahead and add in that perimeter feature. We're going to go to Mill Part Setup. We're going to go ahead and add in a 2.5 axis milling operation. And let's add in a contour. We will use our 1/2 inch flat end mill, and then we're going to go to features, and we're going to create a feature. And we're going to do a part perimeter feature. Give this here a second to recognize that. Oh, let's see if this waits. Give this a hot minute here. There we go. So, if you guys ever experience SolidWorks issues, just be sure it plagues us all. So, no need to worry about that. So what we're going to do is we're going to go ahead and select OK on this. Now it's recognized that outside perimeter feature. We can go ahead, we can select OK. That's going to give us that contour mill, which is going to go ahead and buzz that outside surface. So let's go ahead, before we edit any of our settings, we'll generate the toolpaths for this. And then we can go ahead and simulate this. Now, let's go ahead and do... It's going to buzz through here. It's going to switch to the ball end mill. And then with any luck, this will come in and clean up this outside. Oh, and that looks perfect. That looks good. So now we've got a nice clean outside profile. So before we go ahead and flip over to the other side, which is just going to require us milling out this ramp here, let's go ahead and edit our parameters so that we can go ahead and get a nice smooth finish on this. So with our first area clearance, let's go ahead and edit that 1/2 inch flat end mill. We're going to go ahead, adjust our feeds and speeds. So with high-speed steel, and we'll assume aluminum on this one, our cutting speed or our spindle speed is going to be 2400 RPM with a feed rate of 10 inches per minute. And I have other videos that show you how we generate speeds and feeds, if you want to go ahead and check those out. For pattern, this is where we can adjust our step over, which is essentially how much the cutter overlaps itself. We're not going to worry about that right now. Anywhere about 40 to 50% step over is fine. So we're going to go ahead and leave this. For area clearance, this is the settings surrounding the cut itself, how much material it leaves on. Let's go ahead and remove a little bit more material here. We'll go ahead and set these both to 10 thou worth of material. So that's how much material it's going to leave on the part itself for the contour pass to clean up. For NC plane, I always like to set these to 100 thou top of stock. Your machine and your settings will be different. And then we can go ahead. One more thing we want to adjust in our area clearance is our max cut amount. You generally don't want to exceed 10% of your tool diameter for your depth. So we're going to set this to 50 thousandths. So let's go back and edit that. $50 thousandths for our max cut amount. We can go ahead and select OK. It's going to update that tool path for those new parameters. For our Z level, for our ball nose, this is going to do all the sculpting. Feeds and speeds. If we go ahead and calculate the spindle speed for a 1/4 inch end mill, it's going to be 4,800 RPM. Our feed rate. This is going to depend on a few factors, mainly our spindle speed, our cutter material, and how many flutes that we have. We'll go ahead and we'll set this to a value of 10 as well. For Z level. For cut amount. Now in this case, the cut amount is going to dictate the fidelity of our cut, or the fidelity of the surface. If we have this set high at 100 thou or so, our surface is going to look really stepped. If we set it down lower, it's going to have a smoother appearance at the offset of cut time. So we want a nice surface here. So we're going to go ahead and set this to as low as it'll let us do. So let's try 5 thou. Oops. Let's go back. Keep working on that. And so it looks like 10 thou is what it's going to let us do. That's fine. That should give us a nice finish. For our NC plane, I like to do top stock, 100 thou. And then everything else in here should be fine. So we can go ahead and select OK. It's going to go ahead and recalculate that tool path for us. There we go. And that's going to give us a nice finish. It's going to take a while. That's the offset of cutting that at 10 thou. But it's really one of the only ways to get that good surface finish on there. And we'll see that at the end when we go ahead and simulate this. And then for our contour mill, this is going to be very similar settings to our first operation. So we're going to go ahead, 2400 for our spindle speed, feed rate of 10. For our contour, we're going to set our first and max cut amount to 10%. For our NC plane, top of stock, 100th thou. Clearance plane, top of stock, 100th thou. Depending on your machine, you may or may not have to turn CNC cutter compensation off. On the machines we're working with, we turn that off. Then everything else in here should be fine. Now, before I go ahead and generate or simulate this, what I'm going to do is reorganize these. I'm going to take this contour mill and drag it up if it will let me. Maybe I can take that Z. No, it doesn't appear that it will let me. One thing we like to do is to structure these so that we're doing tool changes as little as possible. Depending on the parameters of the cut, it may not allow you to do that, and it appears that's the same in this case. So let's go ahead and simulate this. Just going to go ahead and rough that all out. Now next is going to be the ball mill, and you'll see it's going to take quite a long time to do this, but you can see the surface finish on there is much better. Now one thing to remember, the surface finish that we see on here is oftentimes a lot worse looking than the part actually comes out in real life. We have the benefit of being able to zoom in really close on these parts and to see all the steps. And there are also resolution issues with Solidworks and how it generates features. So in real life, this part is actually quite smooth. That's gone ahead and contoured that. And then the last operation is going to be cleaning this all up here. And that looks pretty good. I'm happy with that. So now all we have to do is create a second mill part setup for it to cut the backside. So let's go ahead and do that now. So let's go ahead, we'll create a new setup. And we're going to flip our part over. And we're going to select this surface here. We're going to go ahead and do a multi-surface feature. And we're going to come in here and we're going to select all of these surfaces, just like we did on the front. This is how it's going to recognize which surfaces to cut. So we've got that multi-surface feature now. We can go ahead and add in a 2.5 axis feature. And we're going to have it rough mill these out. So this is an open pocket. And our end condition let's see. Let us generate that operations plan. That might be an easier way to go about this. There we go. So instead of going ahead and adding it in manually, we just let Solidworks take care of that for us. We added in that generate operations plan. So it's got the area clearance and the ball mill, so we'll generate those tool paths. And then we're going to adjust these to the same parameters that we have set on the front. The area clearance, feeds and speeds. This is going to be the 1/2 inch end mill. Spindle speed of 2400. XYZ feed rate of 10. We're going to put on a 10 thou allowance, just like we did on the front. And we're going to do a 50 thou cut amount. NC plane, top of stock, 100 thou. And then our Z level for our ball mill, again, it's going to be those same settings that we did on the front. So 4800 spindle speed, feed rate of 10. Cut amount of 10 thou. NC plane, 100 thou top of stock. Now in this, I'm going to delete my mill part setup 1, just so that we don't have to sit through that simulation again. It's going to be the same as it was before. But let's go ahead and simulate this now to see how this backside looks. It's going to come in and rough that out just like it did on the top. And then it's going to come in with that ball mill and sculpt this all down nice and smooth. Now you'll notice it's left us with this perimeter. That material is removed in the first operation, and that first mill setup with the contour mill. So this material is not actually here. It's only here because I deleted that for the purpose of the video. Now, in other videos, we'll talk about fixturing. We'll talk about how we would design this part and hold this part to be actually cut. But from a standpoint of tool paths, I think this video covers it pretty well. So if you guys have any questions on this, or if there's anything you guys would like to see, go ahead and let me know. Otherwise, I will see you guys in the next video. Thank you.